Hi, this is Mr. Coumbe. Let's do another gas stoichiometry problem. Pause this video so you can read the question and let's solve it out. Okay, so here, first off, you are going to need an actual reaction, and this is actually a pretty straightforward reaction. Let's write it up in our yellow maize color. So we have methane or natural gas, which is CH4, and that is a gas. You combust it, and it undergoes complete combustion. Whenever you have complete combustion of an alkane, you're just going to produce carbon dioxide and water vapor. Pretty straightforward. Let's balance this equation because it's slightly not balanced. On the right hand side you have 3 oxygens, on this side you have 2. So what if we double this? If we double this side, you have the right number of hydrogens on each side, but now you have 3 pairs of oxygens. So we have 3 pairs of oxygens, that becomes a 3. Here we go, balanced equation. First things first, we have 45 liters, and this 45 liters is not happening, this combustion is not happening at STP, it's happening at 730 millimeters of Hg. Of mercury, and at 20 degrees Celsius. Now at STP is 760 millimeters of Hg. So we need to find out what is the volume going to be at STP, and we can find that out using the combined gas law, which is P1 V1 over T1 equals P2 V2 over T2. If we plug in all our values, the first pressure is 730 millimeters of Hg times our volume, which is 45.0 liters, and that is at 20 degrees Celsius, so 293 Kelvin. Now at STP it's going to be 760 millimeters of mercury times, we don't know what volume, divided by 273 Kelvin, which is 0 degrees Celsius. If we rearrange to get V2, we get, I'm not going to put in the units, I'm just going to put in 730 times 45 times 273 divided by 293 times 760, and that should all end up to about 40.3 liters to three significant figures, 40.3 liters. Awesome. So now the next part, so this is all at STP. So this is all at STP. Now let's have a look. If that's all at STP, we can find out the number of moles of our methane, the number of moles of CH4, which is V over 22.71, which is 40.3 divided by 22.71, which ends up being about 1.77 mole. And now, according to our molar ratio, we can now figure out the number of moles of our 2 products. So let's do that in orange. The number of moles of CO2 is going to be the same as the number of moles of methane. Oops, CH4. Okay, so to get the mass of our CO2, we get the number of moles of methane, which is 1.77 moles, times the molar mass of carbon dioxide, which is something, if you're doing chemistry, ATAR chemistry, you should know this off by heart, which is 44 grams per mole. And the mass ends up being 77.9 grams to 3 significant figures. Now let's find out the number of moles of our water vapor is twice the number of moles of our methane, CH4, because over here 1 is to 2, so it's twice, and that should be around about, what is that? Let's have a look. Let's just quickly calculate it. What is that? That's about 3.54. So 3.54 mole. So to get the mass of our water vapor, we just need 3.54 times, and this is another number that you should all know off the heart, the molar mass of water, which is 18 grams per mole. So the final mass of water is going to be about 63.7 grams to 3 significant places. And here we go, problem solved.